find the probability that a randomly selected 2 cross 2 matrix with all its entries from the set of first 10 prime numbers is singular matrix, right? Singular matrix means determinant of that matrix is 0. So let us say that these are the different prime numbers. First 10 prime numbers will be starting from 2, 3, 5. Then you have 7, 11, 13, right? Then next will be 17, 19. Then you have 23 and 29. So these are the first 10 prime numbers. Now the question is that using these 10 prime numbers, of 2 cross 2 matrix is created, and we have to find the probability that that matrix will be a singular matrix, right? Now let us say this is our 2 cross 2 matrix A, and there are 4 unknowns in that. Let us say those unknowns are A, B, C, D. So here we have this matrix. In first row, let us say we have A and B, and in second row we have C and D. So first of all, let us find the number of elements in sample space, or the number of matrices that you can create. A, B, C, D, we have to select from this set, right? A, B, C, D are selected from first 10 prime numbers. So for A, we have 10 options. We can select any one of these 10 numbers. Similarly, for B, we have another 10 options, and so on. So total number of matrices that you can create, this will be 10 raised to 4, right? For A, 10 option, for B, another 10 option, and so on. So these are the total number of matrices, or the number of elements in sample space. Now let us count the favorable cases. Favorable case means out of these 10 raised to 4 matrices, we have to find that how many matrices are singular matrix. How many matrices are there whose determinant is 0. Now, see, singular matrix you can create in different ways. One possibility is that you will pick any one number from here, and you will use the same number in all entries, right? For example, let us say if I create a matrix like this, where we have selected any one number from there. Let us say we have selected 2 or 3, any number, and then all the entries are same number. Now, what is the determinant of this matrix? Obviously, the answer is 0, right? So this is one singular matrix. Now, how many such singular matrices are possible? So let us say n1 is the number of such singular matrices where all entries are same. So this will be nothing but 10C1, right? Out of these 10 elements, select any one element and will use the same element 4 times. So all of these 4 variables A, B, C, D will be that same element. So there will be 10 such singular matrices. Another possibility is, second possibility will be that out of these 10 prime numbers, select any 2 prime number and will keep those prime numbers either in, let us say we have selected these 2 prime numbers, maybe 5 and then 7. You can select any 2 from there. So you can keep 5 in first row and 7 in second row. Now again, the determinant of this matrix will be 0, right? If I want, I can keep 5 in first column and 7 in second column, still the determinant will be 0. So let us say N2 is these type of matrices where we are using any 2 of these 10 elements. Now, how many such matrices are there? So step 1, from those 10 matrices, select from those 10 elements, those 10 prime numbers, select any 2 prime number. Let us say we have selected 5 and 7. Now, in how many ways we can do that selection? 10C2. And once you select 5 and 7, there are 4 matrices that you can create. What are those matrices? First matrix where 5 is in first row, 7 in second row. Another matrix where 5 is in second row and 7 in first row. Just interchange these 2 rows. And same thing you can do column wise, right? Or another way of saying the same thing will be that you need to keep uh, the elements of any one row or any one column same. So one matrix where 5 is in first row, another matrix where 5 is in second row, another matrix where 5 is in first column, and finally the last matrix where 5 is in second column, right? So by selecting these 2 elements for corresponding to each selection, we can create 4 such matrices, right? 5 in row 1, 5 in row 2, and that means 7 in row 1, 5 in first column and 5 in second column. In all those cases, determinant will be 0. So the number of such matrices will be 10C2 is 45, 10 into 9 by 2, and that multiplied by 4. So 45 into 4, that means 90 into 2, so that will be 180. So these are the number of matrices where we are using exactly 2 of these 10 elements. Now, using 3 or 4 elements, you cannot create a singular matrix for the simple reason that all of these numbers are prime numbers. Right? For example, if I select 5, 7, and 11, so now you cannot make AD minus BC 0, right? For example, I mean, because all of them are prime numbers, so singular matrix means determinant should be 0. Now, if you select any 3 prime numbers from here, you cannot get 0. AD minus BC, that cannot become 0. And similarly, if you select any 4 prime numbers, then also you cannot make AD minus BC 0, right? AD minus BC 0 means AD is same as BC. Now, product of any two prime number, this will not be same as product of any two other prime numbers, right? If I have selected these 4 prime numbers, so A into D is not same as B into C if they are different numbers. So therefore, these are the only two matrices, right? These are the only two possibilities that we have. Either all 4 elements are same or any two are same, remaining two are same, and the same elements are in any one row or any one column. So now the question is, we have to find the probability that the matrix will be a singular matrix. So total number of singular matrix, this we are getting 190, right? 180 in second case, 10 in first case, and this divided by 10 raised to 4. So after simplification, this will be 19 by 10 raised to 3, and therefore the correct answer for this problem will be option C. This was an interesting problem, and because all the prime numbers are involved, so we are getting only these two cases, because product of any two prime number is not same as product of any two other prime numbers. So 190 favorable cases, total 10 raised to 4, probability will be 19 by 10 raised to 3, and hence the correct answer is option C.